Alright guys, welcome to Math0314 1.5 Compound Inequalities. Alright, so the first bit of this is kind of a review of what we did in the previous course. The first statement is saying what is A union B, and union means that if I have two groups, group A and group B, union is everything. So everything in group A and everything in group B, which means it's everything. So the best way of doing A union B is if A is A, B, C, D, E, F, then I want to take, let me do this to create some space. Let me take that away. Then I'm going to take every element of A. I'm just going to write out A. And then all the elements of B. Now, we usually don't write things if they repeat. So we can see A, C, and E are all repeating from A. And then we have G, I, K. Okay, so it's everything in A or B. And that's actually what this is also known as, A or B. So you can choose from A or you can choose from B, and it's all of those elements. In B, we have what's called intersection. An intersection is just what they have in common. So this is called intersection. And it's just, this is A and this is B. It would just be where they overlap, just what they have in common. So we can see they both have A, we can see they both have C, and we can see they both have E. So the answer is A, C, and E. Okay? So if this is making sense, pause the video now and try to do letter C. Okay, so I'm assuming that you've had a go at it. This is C has an intersection, A intersection C, so let me do this. Let me erase the erasing. And A and C. So I just look at A and I see what does A have in common with C. And we can look through and we actually see that they have nothing in common. When this happens, we actually draw what's called the empty set. And that's it. That's all you have to do. So union just means it's everything. Intersection means just what they have in common. Okay. So here's the next set of problems. Pause the video now and give it a go. And I'm going to assume that you've paused the video and you've given it a go. And let's run through these real fast. So B union C. Again, union means what? Union means everything they have. So I rewrite the B, which is S, V, W, Y, Z. And then I'm going to write C, what is with C, but not in, I'm going to write what's in C, but I'm not going to repeat anything. So Y and Z are the last two letters in both, so I won't write those down. X is the only one that isn't in B, and that's going to be my answer. Okay. B says A intersection B, and that means just what A and B have in common. So I'm just going to look at A and see what they have in common. They have S in common, and they have V in common, and they have W in common. So S, V, W, S, V, W. Alright, I'm going to have to, let me do this. So I said what, S, V, W. Okay. Alright, A intersection C. A intersection C is just what A and C have in common, so I'm going to use C because C's last. I'm going to see, does A have an X? No. A Y? No. A Z? So again, it's the empty set. So hopefully that makes sense. Hopefully that's a review, and you recall that from the previous course. Question number 3 is given A, and the way we read this, X such that, this bar means such that X is less than 3, B is X such that X is greater than or equal to -2, and C is x is greater than or equal to 5. And we're asked to graph the intersection of A and B. So let's do this real fast. Let's quickly write out what these represent. So x is less than 3. We know that this means that it's 3 and less. X is greater than or equal to -2. It's going to be over here at -2. And x is greater than 5 is going to be here. And then what I want to do is let's just fit it all here. Let's just put them all on the same picture. So that's less than 3. That's greater than -2. And that's going to be greater than 5. And this way, now that I look at it, I can see everything all at once, and I don't have to overthink it. So, we know that intersection means, let me do a neutral color here. Intersection means just what they have in common. So, A is in green, B is in red. So, the intersection we can see is this right here, which is between -2 and 3. Bracket in parentheses. And you do have to put it in bracket in parentheses. A union C means everything in A or in C. So A is in green, so that's back at 3, and then C is greater than 5. So that's actually going to be two things. So we're going to actually rewrite both of them. It's going to be -infinity to 3. Then we're actually going to use the symbol U, and the other one's going to be, oops, 5 to infinity. And this is the case because the green one is all the way over here, and the yellow one is over here. They don't have an overlap. In fact, there's a gap right here, right? And that's okay that there's a gap there. What we want to realize is that when that gap occurs, we have to use the symbol OR to indicate what's occurring. Okay? And that's about it. So hopefully that makes sense. Go ahead now, if you haven't done so, pause the video and try number 4. Okay, so hopefully now you've given it a go. As you can see, the screen's changed a little bit. Went ahead and graphed them all, see if your information balances up with mine. And let's answer these questions at the bottom. So it says A intersection, actually let me choose, neutral color here is going to be red here now. A intersection B. So A intersection B is A, which is in purple, B, which is in green. So intersection is just what they have in common, which is this region right here. So we can say it's -1 to 4. Union means it's everything of B and everything of C, and we're going to see the same thing as before. So 4 is still here, and 9 is over there. In other words, B is the first one I drew out, and C is the second one. So we're going to have the same sort of thing. So we're going to say -infinity to 4 union 9 to infinity. Okay? And I'm assuming, by the way, let me go back here. I'm assuming that you guys are okay with this. This is called interval notation. But this just literally means from -infinity, right, to 3. Right? And this just means from 5 to infinity. And I actually think in general interval notation is easier to write than this notation here, which if you recall from the previous course is called set notation. It's a lot easier to look at. I think it makes more sense. But mathematicians jump between the two. You should be comfortable with both. Let's move on. Okay, so now we're asked to find the union or the intersection of each of the following. So basically it's asking us to say what is the final result of each of these. So we're kind of doing what we did before, but in reverse. So what I would do again with each of these is graph it. So if you want to pause the video, I'm just going to label what's going on here. So the first one's going to be negative infinity to negative 2. So let's say this is negative 2. We're going to go out here. The next one's negative 4 to 3, including negative 4. So here's negative 4. I went too far. Negative 4, and it stops at 3. Okay, so union would be all of this, right? So if I say all of this, that means I'm going all the way through here, which means that the answer would be the union would be negative infinity to 3, right? If I do the intersection is just what they have in common, which would be this region here, right? So the intersection would be negative 4 to negative 2. Okay, because it's just what they have in common. So they just share negative 4 to negative 2 in common. So my advice in each of these is to draw a picture of what's representing, what each question is representing, draw it out, and then write your final answer. Okay, so go ahead if you haven't done so. I want you to go ahead and try to do B, C, and D. Okay, so B, C, and D. So pause the video now and go ahead and try these real fast. Okay, so let's try B. So in B we have a number line. It's going from negative infinity to negative 2. This is not including negative 2. And then we have from negative 4 to 3. Here's negative 4. Here's 3. Now, unlike the previous one, this is intersection. So intersection is just what they have in common. So this is just going to be from negative 4 to negative 2 because it's just what they have in common. Okay? So C and D, more or less the same sort of idea. The first one will be negative infinity to negative 5. There we go. The next one's going to be negative 7 to 0. And again, this is saying union, so union is all of this, which means we'll include the red part here, all the way through here. So we'll say from negative infinity to 0. But, if you'll permit me, the next question is talking about the intersection of the same thing, so we're just concerned with this. So it'll be from negative 7 to negative 5. And there you have it. So, draw a picture. Make sure you know union means everything, intersection just means what they have in common, and you'll be fine. Moving on. Solve the inequality. Now remember, and means intersection. So what we want to do is exactly what we've been doing. The only difference is that we have to solve the inequality first. We'll divide by negative 2. And just like we discussed in the previous video, we have to flip the inequality. Here we'll subtract 5. So we'll graph both, and we'll do the intersection of these two. So if we graph both, we see that the intersection is just what they have in common, which will be from negative 3 to 7. So the goal here is this, just exactly what we've just been doing. It's just you have to make sure you know and means intersection, and you know how to label these. So you're basically taking the skills from 1.4 and implementing them here, and you'll be fine. Okay? So do me a favor if you haven't done so already, pause the video, try these real fast, and then we'll go over them together. So, assuming that you've paused the video and you've given this a go, let's solve them together now. So we're going to subtract 2 from both sides. So 5x is greater than or equal to negative 10. Divide by 5. Note here, we're not going to switch the inequality, whereas over here, we did switch the inequality. And the reason we switched here is because it was negative, but here, That's positive, so we'll leave it as such. However, on the next one, when we divide by -4, we are going to flip the inequality. And I wanted to write negative, but it's not negative. It's going to give me 6. Okay? And to finish it off, we just graph on a number line. So x is greater than -2. Note we are including, so, and x is less than 6. Since this is and, we are talking about intersection, and we're done. And there's my answer. Okay. So, on this one, they're giving us decimals to try to trick us, but just like we learned in section 1.1, we can multiply through. In this case, I'm going to multiply by 10, and I'll get rid of the decimal. And I'll do the same thing here. There we go. Okay. So, if you haven't done so already, pause the video and try to solve from here. I'm going to assume you've done that, and I'll just keep going. So we're going to subtract 31 from both sides. We're going to get -154 is equal to 44a. Finish it off, divide through by 44, and look at me, I put equal. Less than. Divide through by 54. And a will be less than negative. Will give me 3.5. There you have it. Notice here, we don't have to flip the inequality. The top is negative, but it's what you divide through by. So if I'm dividing through by a positive, it's going to stay, the inequality doesn't flip. Okay, let's do the other side here. More of the same. So we're going to subtract 91. Sorry, it's a little smash there. Interestingly, we get the same thing. And 154, I forgot to put a 4 there. And then we'll divide by -28. And here we're going to switch the inequality, and this is going to give me 5.5. Okay, so we are saying and, so we're going to do what they have in common. So the first one is less than -3.5, and the other one is greater than 5.5. So we can see here that they actually don't share anything in common, so when this happens, we get the empty set. So hopefully that makes sense. On to the next one. If you haven't done so already, pause the video, give it a go on your own. I'm going to assume that you've done so. Same sort of thing. I'm just going to rewrite it as 32y minus 24 greater than 168. And then the other side is just going to be -41y is greater than or equal to 82. Now, hopefully you can tell me why. The answer should be that, just like in the previous example, you multiply through by 10. Okay, so solve it like normal. Add 24. y is greater than 192. Finish it off by dividing by 32. And y is greater than, and this should give me 6. We'll do the same thing on the other side. We're going to divide through by -41. Y will be less than or equal to -2. Now, hopefully you can tell me why I flipped the inequality. Hopefully you said because you're dividing through by a negative. Again, here we're going to graph. First I'm going to graph y is greater than 6. And then I'm going to graph x, or y is less than or equal to -2. Again, if this is and, this means they have nothing in common. So we have the empty set. Okay, moving right along. Next up, we have these. So more of the same. Pause the video, give it a go, see what you can figure it out. Okay, I'm going to assume that you've done that. To get rid of the negative 2/3, I'm actually going to multiply by negative 3/2 on both sides. That is the reciprocal, and that will get rid of the numbers here, and will leave me with just with x. Remember, if you multiply by a negative, you have to flip the inequality. 2 goes into 6 3 times. This is going to leave you with negative 9. On the other side, I'm going to multiply through by negative 2 to get rid of, because the reciprocal negative 2/1. You do one side, you do to the other. And this is going to give me x, again, you got to flip it, is greater than negative 2. Now when I graph this, x is greater than or equal to negative 9, and x is greater than negative 2. So the first one is all of this, the second one starts at negative 2. What is the intersection? The intersection is what they have in common, which is just the negative 2. So we'll say negative 2 to infinity. So I think if you just draw a picture to illustrate what's going on, this is not nearly as difficult as it initially appears to be. Okay. So again, once again, if you haven't done so already, pause the video and give it a go. I'm going to assume that you've done that, and we'll do it together now. So I'm going to multiply through by negative 4, or negative 4/1, because that is the reciprocal. This will give me z, because I'm multiplying by a negative. I have to flip the inequality. 4 goes into 8 2 times, so this is a negative 5/2. On the other side, I'm going to multiply through by 2. Oh, wait. This one I'm going to subtract 1 first. And you always want to do this. You always want to put stuff that you can together first. And then we're going to multiply through by 2. So z is going to be greater than or equal to 4. And z is going to be greater than negative 5/2. So we're going to draw this out. Here's negative 5/2. Here's 4. They're both, z is greater than, so they're both going to be just like the last problem. And just like the last problem, we're concerned with only where they intersect. So the intersection is at 4 or more. Alright, here what we see is, this is an and statement. This actually means negative 4, 3x plus 5, and 3x plus 5 is less than or equal to 10. So we can combine them together into one sort of inequality, just to make it a little easier on the eyes. And the approach here is just like you would solve a basic equation. So we would just subtract 5. Now you have 3 sides, so you have to subtract it from all the different sides. And we'll get negative 9, 3x, 5. And this, if you think about it over here, this makes sense, because if I subtract by 5 on both sides, I get negative 9 is less than 3x, and here I subtract 5, I get 3x is greater than or equal, or less than or equal to 5. So it's the same thing, right? And that's why you can do that. And then the next move is to divide through by 3. And this gives me negative 3. I do have to be careful here. Oh, no I don't. I'm fine. So, I was looking at that wrong. My question to you is, why did I not flip the inequality? Hopefully you said it's because I did not divide through by a negative. And that's it. And that 5/3 looks a little intimidating, but this is just saying between negative 3 and 5/3. Notice here we have lines because this is a line, or in other words, it's including 5/3. Okay. If you haven't done so already, this is supposed to be a 5. Go ahead, give it a go on H. Assuming that you've done so. Let's do it together. So I'm going to add the 5. Again, if you add 5, you have to add it to all the sides. Okay, and then I'm going to divide through by 2. graph is just like the last one. We are including between these, and that's your answer. Looking at I, go ahead. I think you guys can do this on your own, so stop the video and try to do it on your own. Once more, I'm going to assume that you've done so, and all I have to do here is multiply through by -3. So you're really just employing the same strategies you've used in the past. With equations, they're just inequalities. You just have to remember the rules of inequalities. So again, if I multiply by a negative, that means I have to flip the inequality. Right, and you gotta flip it on both sides, right? And all I have to do now to finish it off is add 2. Hopefully that's what you said. And there we have it. So once more, pause the video if you haven't done J, and give it a go. I'm going to assume that you've done so. How do I do this? The same exact way as I did the last one. So we're going to get rid of the fraction. By multiplying through by -2, we get -16 again. Because we're multiplying negative, we've got to flip the inequality. Subtract 4 to get the variable by itself. And there we have it. Okay, so this next one, if you look at it, it says or instead of and, so this will be interesting to see what happens. Let's just go ahead and solve it like normal. We're going to add 5 here. And what I'm hoping, again, that you're seeing is that once you understand how to solve an equation, a lot of this becomes very simple. A lot of it becomes pretty redundant. I want you to notice that when I divided by -3, I flipped the inequality. And do the same thing on the other side. Subtract 4. -y is less than 2. And again, I'm going to divide by -1, which, to get rid of the, there's technically a -1 here, right? And to get rid of that, we have to divide through by -1. And upon doing so, I get y. Remember, we got to flip the inequality. Divided by a negative is greater than -2. So let's graph what this one looks like. So y is less than -3 is here, and y is greater than -2 is here. Okay. Now on this one, when you're looking at it, there's a part of you that maybe wants to say it's the empty set, but here, note the difference. The previous ones, we've been doing different versions of and. This one is an or, and with an or, we are saying it's everything. So it's okay to say the final answer is -infinity to -3 union, we're going to space there, -2 to infinity. And that is my answer. So when it's or, you include both. When it's and, it's just what they have in common. If they don't have anything in common, then it would be the empty set. Okay? Pause the video and give it a go here and see if you can solve this one. So I'm going to assume that you've given it a go. Hopefully this feels like it's more of the same. I'm going to add 8 to both sides. Get -10x is greater than 20. Divide by -10. X flip the inequality. It's -2. Approach the other side the same way. Add 6 to both sides. 3x is greater than 9. Divide by 3. X is greater than 3. So the answer is going to be over here and here. Or simply -infinity to -2 and 3 to infinity. And there's always a union. Okay, so hopefully that makes sense. So on the next one, I'm almost out of time. Just want to quickly show you that when you solve this one, what ends up happening is that you end up getting everything sort of shaded, and because it says or, that means your final answer is going to be -infinity to infinity. So hopefully that makes sense, and I'll see you in the next video.